Today we're going to start by talking about comparing ratios. So, a quick look at comparing ratios. When we're going to compare ratios, there are two strategies that we can use to see if both of the ratios are the same. Our first strategy is we're going to see if we can make equivalent ratios that are the same for both ratios. The second strategy that we can use is a new strategy that we call cross multiplication. So, equivalent ratios. We have this example where Dan is making a volcano for a science fair. His first volcano, he makes a mixture of 2 tablespoons of baking soda and 6 tablespoons of vinegar. His second volcano experiment, he tries 3 tablespoons of baking soda and 9 tablespoons of vinegar. And what we want to know is, did Dan use the same ratio of baking soda to vinegar in both eruptions? So first things first, I like to use tables because they help me keep organized. And I'm going to go ahead and fill in what I know. So for volcano 1, we know that Dan used 2 tablespoons of baking soda and 6 tablespoons of vinegar. So I go ahead and fill those in the appropriate space. Now for volcano 2, we know that Dan used 3 tablespoons of baking soda and 9 tablespoons of vinegar. So again, we're just going to put those in their correct space. Now, this is where knowing either common factors or common multiples comes in handy. You need to pick what you're going to compare. In this case, I'm going to compare baking soda to baking soda. And I know that 3 and 2 have a common multiple of 6. So I'm going to try to scale my baking soda for both of them up to 6. So for volcano 1, I need to multiply my 2 times 3, which means I also need to multiply my vinegar 6 times 3. And so I get 6 baking soda and 18 vinegar. And then for my volcano number 2, I know if I want to scale 3 tablespoons of baking soda up to 6 tablespoons of baking soda, I've got to multiply by 2. And so if I multiply my baking soda times 2, I've got to multiply my vinegar times 2, which gets me 6 and 18. Now, lastly, I just have to look at my final answers. I have 6 and 18 for volcano 1 on a baking soda to vinegar ratio. I've got 6 to 18 baking soda to vinegar ratio on volcano number 2. If both of my ratios are the same, when we scale up or scale down our ratios, then they're the same ratios even if they start in different places. Now, our second strategy to me is a little easier. We're going to use the same example, but we're going to do something called cross multiplication. And in this case, I'm going to write my ratios as fractions. So I've still got my 2 tablespoons of baking soda to 6 tablespoons of vinegar for volcano 1, and I've got my 3 tablespoons of baking soda to 9 tablespoons of vinegar for volcano 2. And what I'm going to do is I'm just going to set an equal sign because that's what we're going to try to solve. Now, basically, you're going to multiply from corner to corner. So I'm going to multiply my 6 and my 3, my opposite corners, and I'm going to say 6 times 3 equals 18. Then I'm going to multiply my 2 and my 9, that opposite corner, and I'm going to get 18. Now, if we get the same answer for both times that we multiply, our ratios are the same. So these are two different techniques, two different strategies that you can use to find if two ratios are the same ratio or if they are both equivalent to each other.